So we'll be talking about the Gateway API or the Gateway API Inference extension. We just realized there was a discrepancy between the title on the schedule and on the slides. But basically, they mean the same thing. The instance inference gateway is the same thing. My name is Abdel. I work at Google.
And I'm Daneyon Hansen. I'm a principal software engineer at Solo.io.
So before we get going, we'll start with a quick primer on the Gateway API. You probably have seen these slides multiple times in different formats. The Gateway API is the next-gen Ingress API. It was introduced back in 2019 as a separated project, part of the cloud native ecosystem. And it builds on learnings from the Ingress API, which you probably have all used. The whole idea of the Gateway API is to try to solve some of the limitations that the Ingress API had. Some of them is the separation of duty, being able to define resources in different namespaces and make them point to each other. Another one is the permission model. With the Ingress API, you didn't really have a permission model. Everything had to be defined by the team exposing their application. With the Gateway API, we have these various objects that allows us to define the load balancer itself using a gateway separated from how the routes point the load balancer to the different backends using something called an HTTP routes. There are also TCP routes, UDP routes, and other types of routes. But the thing with the Gateway API, similar to the Ingress API, is that it was mostly designed to do web kind of traffic, right? Sadly, we live in 2025 where LLMs are around us, and whether we want it or not, they are a big deal. And the thing with LLMs is that they are not a typical web application. LLM traffic is not your typical web traffic. There are multiple reasons why. One of them is the size of the response and requests. Usually, web traffic have very short, very frequent response and requests, while LLM traffic the size of the request can be big, depends on the prompt. And it also can be big because some LLMs support multimodal. They support video, audio, so the size of the inputs or the output could be big. An LLM can actually take more time to process a request. A lot of LLMs support streaming, where you send the prompt and then it streams the responses back to you as the LLM is thinking and generating the outputs, which means that the processing time can be very long. And it's not like web requests where the requests are very short. The processing time can take time, as I said, and the requests in a web traffic, sometimes the requests could be similar, or the responses, sorry, from the application could be similar, which could be cached. But in the LLM world, a lot of times the responses are the same. And we actually use a lot of caching techniques to make LLMs more efficient, because you would ask the same question, get back an answer, and then ask the question again, or ask a follow-up question, and then you will get back the answer, which probably contains the same prompts. So these are just some of the differences. So what is the inference extension? It's essentially an extension of the Gateway API to support inference traffic. And before we move any forward, we actually thought it would be useful to explain what inference is, because the word is used interchangeably many times. I have a very stupid way of explaining inference. You can think about, if you think of a web application as a combination of HTML, CSS, and JavaScript, those three things are useless if you don't have a web server. You need a web server to be able to talk to a website. The same way for an LLM, you need an inference server to be able to talk to an LLM. LLMs are created differently, they have different architectures, and they are for the most a very big file. You need something that knows how to talk to the LLM, prompt it, get back the responses, and return it back to you, whether you are a user or an application, in a standard format, so a REST response or a gRPC response. So that's what an inference is. And so in the inference space, there are multiple open source projects, VLLM, TGI, Triton, Olama, etc., etc. So think about inference as the web server. I'm putting quotes here, air quotes, the web server for a web application. So how are we doing this? Well, we are providing some APIs for doing routing decisions that are specific to inference workloads, and we're going to talk about it later in details. We're also providing a bunch of specs and some reference implementations for those specs. We'll talk in details, but some of the specs are being able to grab the model name from the body of the request, so we know where to route the traffic exactly. And then also providing some integrations for various APIs that are new to the inference extension.
So let's talk a little bit about the project use cases that were used to really form the project just a few short months ago. I've come a long way since starting the project at the end of 2024. But the first, most obvious use case is model-aware routing, right? So Abdel talked about Gen AI traffic is very different than web traffic, right? And a big part of that is that in inference traffic, we've got the model name actually in the body of the request. And so being able to use that model name to perform routing is one of the key use cases of the project. And we'll talk a little bit more why that is important, but also serving priority, right? You may have different models, some that have higher criticality than others. A good example is a summarization model is not as time sensitive as, let's say, your chat model if you have a chat bot. And along with another use case is model rollouts, right? So if we're familiar with being able to manage web applications, we know that we have to roll out newer versions of that web application over time. We take that same thought pattern and bring it into inference. And Abdel talked a little bit about Gateway API and the resources associated with Gateway API, and one of the big successes for Gateway API is that the APIs were defined based on personas, right? We learned through Ingress that a single resource does not work because there's different personas that manage how Ingress works within a cluster. And Gateway API Inference Extension extended that model and those personas with an inference platform owner and an inference workload owner, and creating an inference pool that is managed by the inference platform admin, and then an inference model that's managed by the workload owners. We'll talk a little bit more about those two resources as well. But wanted to kind of do a day in the life of an inference request that comes into the system, right? And so a user or some system makes a request. In this example, it's to your V1 chat completions endpoint. That gets routed to a gateway. And typically that gateway in a web application would perform some kind of layer 7 analysis, right? Based on maybe the path of the request or certain headers, and then route that request to a certain backend, right? For inference and with the inference extension, that gateway, now as that request comes in, it's able to go ahead and say, wait a second, this is an inference request. Let me forward it over to this extension. In this example, the endpoint selection extension, which you may also hear it referred to as the endpoint picker. The gateway forwards that request over to this extension. And typically that extension is running as a separate pod and service. And so we'll talk about how the gateway discovers that, but the gateway forwards that request over to the endpoint selection extension to make a determination on what endpoint that the traffic should be forwarded to. And how does that endpoint selection extension make that determination? Well, on the back end, it's getting these live reports from all of the different model server pods that make up an inference pool, right? So an inference pool, we think of that as an abstraction to abstract away the hardware, the shared hardware, like GPU resources that are used to run your model servers. And based on that live reporting, things like KV cache utilization, which model servers have which fine-tuned adapters loaded and so forth, it gets to make this very intelligent decision on where to route that traffic to. And when it makes that decision, it forwards it back to the gateway and says, hey, gateway, use this endpoint, this IP address to forward that traffic off to. So now with that understanding, let's take a little bit deeper look into the inference pool resource. Again, this is a resource that's going to be managed by the platform admin. And this is an abstraction, as I mentioned just a few minutes ago, as a way to abstract away all the resources used to support inference for your model servers, right? And so as we look at the specification here, we see that we use standard selector mechanism to use labels on all of your different model server pods and to group those pods together using this selector mechanism. And then there's a target port number, right? So as the request comes in, we want to know which port should be used as we forward the traffic to the final destination of those pods. And then you see an extension reference, right? So I mentioned that the endpoint picker is a pod that runs separately from your gateway, typically has a service to abstract away the pod, where you may have multiple instances of that pod. But this is used by your gateway to discover where this endpoint picker is running and how to communicate to it, right? Because if that gateway is going to go ahead and say, oh, I need to forward this traffic to the endpoint picker to decide which endpoint that I should route to, I need to somehow tell the gateway this is where this endpoint picker resides. And then the inference model is, again, the persona assigned to the inference model is going to be your workload owner. And the inference workload owner is able to say, here's my target model, so I can go ahead and take that model name from the body and then change it to the target model as it goes and hits your inference server. Why is that important? Because again, I may want to do traffic splitting, I may want to do canary rollouts based on weights you see here. And so this is a quick overview of the inference model resource as well. Okay. So we did have a slide here on the benchmarks. We did some benchmark testing. You're going to see a Kubernetes blog post that myself and some of the other maintainers created that's going to be coming out that details the benchmark testing that we've done, that we've accomplished. So take a look at that, or you could even go to the website here. So if you'd like to learn more about the project.
Yeah, scan the QR code and then get involved, open an issue if you have any ideas. We'll leave that up for a few seconds, and that's all for us. Thank you very much.
Thank you.
Thank you.
I don't think we have.
All right, so thank you very much. This was a nice overview of what's coming. There is time for one question if someone wants a quick one. Yeah, there is one there.
Hello, yeah. Thank you for the talk and introduction. So my question is, in the previous talk, this KV cache locality is important for the whole system. So in your, thank you. So in your gateway design, where should we implement that prefix awareness in routing?
Where should you plug the KV cache, essentially, in the gateway API?
Where should you plug in the KV cache?
For example, if we have some system to reuse KV cache.
If you have a system to reduce KV cache, where should you plug that into the system? That might even be that might be an opportunity to actually create an extension based on that KV cache system. Or what we're also looking at doing is the endpoint picker or the endpoint selection extension. We're looking at making that pluggable. And so right now, the endpoint selection extension, based on the API semantics that I shared with you, it knows about all the pods running in a particular pool, and is directly communicating with those pods to scrape metrics from those pods of KV cache utilization and so forth. We basically have a spec design for all the different model server frameworks to follow. So it doesn't matter if it's Triton or VLLM, we can go ahead and have a consistent set of metrics that are used to formulate the scheduling decision, right? And so one of two things could exist is either being able to, like I said, make the scheduler a little more flexible, and instead of pulling that from the pods, we pull it from this system that you're talking about that has this KV cache awareness, right? Mm-hmm.
Will the extension API right now being able to pass the, for example, the input content prompt, or it's just getting the metrics?
Yes, right now the scheduler for the endpoint picker is using the metrics that it's pulling from the endpoints.
Gotcha. So it can't really pass the content of the data in the request, right? So because KV cache awareness, you need to understand the input context and the prompt.
So the endpoint picker does not see the content of the prompt. The prompt gets into the gateway, and then the endpoint
gateway extension actually passed that, right?
All right.
Right. So the request, the entire request, the header, the body, the trailer does get sent to the endpoint picker. But the endpoint picker, from a scheduling standpoint, what it's looking at in the body is really just the model name. And again, as use cases evolve, we could look at either extending the endpoint picker, the scheduler, introducing a new extension. So what I would urge you to do is use that QR code, go to the site, maybe even open up an issue or a conversation about the use case that you're sharing with us today.
Okay.
All right.
Thank you.